Video, I'm going to be talking about how to find the surface area of a sphere. Sphere is a three-dimensional circle. There are some cool little visuals found on YouTube for describing how the formula for finding the surface area of a sphere comes to be. Here's a good link right here. Feel free to copy that down and watch that. There's some cool little visuals, ways that we can turn spheres into things like cylinders or triangles, in a way to prove that this is really the formula. But there's also some other cool things that we can do with this formula. A lot of times textbooks or websites will tell you that the surface area of a sphere is 4 times the radius squared times pi, which is essentially r squared pi is the area of a circle. And so one thing you can think about is that the surface area of a sphere is really 4 two-dimensional circles wrapped around a three-dimensional sphere. And that's kind of hard to prove in real life. And again, this video will kind of tell you why. But there are some other ways that we can think about it as well, and some other, maybe some shortcuts we can use depending on what information is given to us in a problem. So if a radius is given, then it's pretty straightforward. We just plug it into this equation and we get the surface area of a sphere. But oftentimes problems are not that easy. They'll give us other things like diameter, so we'll do an example of that. And then to make it even trickier, problems may give you something like circumference instead, and then you have to work backwards in a way to find your surface area. So we'll do that as well. In order to do that, though, it's kind of cool to use one of these little shortcuts here. And here's a little quick proof for you for why those formulas also work. We know that the diameter is double the radius. So if I square double my radius, I'm squaring 2, I get 4. I square my radius, I get r squared. So squaring both of these means that diameter squared is equal to 4 times the radius squared. We'll notice that we have 4 times the radius squared in our equation right here. So we could simply substitute 4r squared with d squared, and then we can use this equation if we're ever given diameter. We could just square the diameter and multiply by pi, and that would also give us our surface area. And then one more other quick way that we can use another variety is we know that the circumference is diameter times pi. So if I pull this apart, this is d times d. If I just replace d and pi in this formula with circumference, then I have an extra d left over. And so another way that I could find surface area is doing diameter times circumference. So these 3 versions of the formula are helpful depending on what information you're given in the problem. And we'll see that as we do some examples here. In this first example, we're told that a spherical water tank has a diameter of 19.5 feet. And so let's use that to find the total surface area of the tank. One way that we can do it is find the radius given the diameter. Let's just cut that in half, and then we can use this first formula. So square the radius first, and then multiply by 4 and pi. Always do your exponents before you multiply. And we could get the surface area is about 1,194.59 square feet. But since we're given the diameter, wouldn't it have been easier just to use diameter squared times pi? So we would get the same exact answer if we did 19.5 squared times pi and then rounded, and we should get the exact same thing. All right, just to step it up one more time here. Instead, we're given circumference, and we'll have to find the surface area. This time we're told that a basketball has a circumference of 29.5 inches. And we want to know how much material is needed to make that basketball. So we're going to find the surface area of material. So given the circumference, one thing that we could do is we could solve for the diameter. We could divide both things by pi here. And so the diameter is circumference divided by pi. So we could plug in 29.5 and divide that by 3.14, only because we're told to use that for pi here. And we could get our diameter and round it. And then we could cut that in half to get our radius, and then we could plug that into our radius squared times 4 times pi version of our formula. But again, that would be silly since we have a version that says that it's just circumference times diameter. So if we found our diameter and we knew our circumference, then we could just multiply those two things and get the same answer. Or since we know our diameter, then why don't we just square that and multiply by pi? So all three versions here are in play. You choose which one you would rather use. Either one should get you the same answer of about 277 1/10 square inches. Just because that was a tricky one, gave you one more to do that's just like it. And this time we're going to do a baseball, given its circumference. How much material is needed to make a baseball? Well, knowing that 9.25 inches is about the circumference of a baseball, then we can do the exact same steps we did on that last example. We could solve for the diameter, taking our circumference divided by pi, and use 3.14, and get a diameter approximately rounded to 3 decimal places, because we're going to continue to use that value. And then we could square our diameter, multiply by 3.14 pi. We could take our diameter and multiply by its circumference. There's another way to do it. Or we could go the long way, cut our diameter in half, get our radius approximated, and then square our radius and multiply by 4 and pi. All three versions giving us similar answers, about 27.2 square inches. And one more example. This example is just going to test our capabilities of our calculator and see what kind of limits our screen has. Some calculators can only display so many digits, so when you start to do problems in planetary size, then numbers start to get really big. And so you may find that your calculator has limits for displaying the number of digits for answers, and it may even try and give you like scientific notation instead. So that's what we're just playing around with here, just to see what our calculator can do. If the diameter of the Earth is given to us, then we can approximate its surface area. Again, we got one of those three options. We can take the diameter squared, multiply by pi, and we get our surface area. We could take the diameter, cut it in half, and then use that original formula, square the radius and multiply by 4 pi, and we should get the same thing. So the surface area of the Earth is approximately 196,936,410 square miles. However, when we think about the Earth, we know that the majority of it is ocean or water, and so really there's only about 25% that's actual usable land for the surface area, and even many of that land area is not really usable either. So even though this is the surface area approximately of the Earth, much of that is water and not very usable for us. All right, so there's some examples playing around with surface area of a sphere. Again, most textbooks will only give you this one formula, so I like to give students these other varieties because it definitely helps when we're given other information in the problems. So good luck finding surface area of a sphere.